All right, everybody, welcome to part 2 of how to count things. This time I'm going to talk about circular arrangements. Okay, so this question is, how many ways can 3 friends sit in a circle? Well, let's call them A, B, and C. So A, B, C, right? Say that's my circle. Well, at first, you might want to say, oh, 3 factorial, just like everything else, right? Because I don't have any replacement here. So once one person chooses a seat, sits down, there's 2 left, and then so on. But there's a bit of an issue here with circular. Notice I could simply rotate, and rotate. So it all has to do with the perspective, right? Of where you're looking at the 3 friends from. If you actually think about it, like if you're person A, you really, as far as in the perspective of who you're seated next to, you're guaranteed to be seated next to C and B. The only question is C on your right and B on your left, or vice versa? So there's really actually only 2 different ways that these friends could arrange themselves in a circle, assuming that there's no like fixed points, okay? So how would I get that? Well, again, I start with my 3 factorial, okay? But then I can rotate, right? I can rotate this arrangement 3 times, and B would still be on the same side of A, and C would still be on the other side of A. So those are called rotations. So with circular arrangements, you have to divide by the number of rotations that are considered equivalent. So in this case, 3 friends sitting in a circle is 3 factorial over 3, or in other words, 2 factorial. So you could look at it as n factorial divided by n rotations, or you could just look at it as n minus 1 factorial, okay? And that's just the straight circular arrangement. But again, be careful. If there is a fixed place, if there's something unique or special about one of the places on the circle, it would then be treated as a linear arrangement, because as we rotate around that fixed position, there's a different person at that fixed location, okay? So it's only if there's just a true circle with nothing fixed in it that you would use this formula. Okay, and then that brings me to the other type of circular problem. How many ways could I arrange, in this case, 3 keys on a key ring? Okay, so I actually have a quick little key ring we can look at here. Here's my 3 keys. I got my house key, my mail key, and my pool key. Now, it's a circle, right? My key ring's not exactly a perfect circle, but it's basically a circle. Now, again, notice you would start thinking, oh, it's 3 factorial, but hey, as I rotate it, now this is really the same arrangement, right? And I can rotate it again. So as I rotate it, I just keep getting really the same arrangement. There's no need to, in other words, take the key off the key ring and move them all, a third of a turn. So you might start thinking, okay, 3 factorial divided by my 3 rotations, or, n minus 1 factorial. And again, that brings me to the point where, like my house key, right? The only question is, do I have my mail key on the left and the pool key on the right, or vice versa? But notice, with the key ring, I could simply flip it over. And now I still have the house key on the bottom, but now I have my mail key to the right and my pool key to the left. So this has what we call a reflection. So anytime I can turn something over, I've cut everything in half, right? The number of orders. So when I have a circular arrangement, okay, with a reflection, circular with reflection is going to be n minus 1 factorial divided by 2, because I have 2 sides that are indistinguishable. So this would actually be 2 factorial divided by 2, or in other words, there's only one way to do it. Right? I could simply, by rotating the keys or by flipping my key ring over, not chain, key ring, I could get the keys in any possible order as far as, you know, pool key on the left or the right of the house key without actually having to take them off of the ring. Okay. Now, of course, there's other things we could be asking. We could, you know, say, people are seated at a table for a wedding and you're going to alternate them by, you know, by gender or whatever. But these are the basics. So from here, you should be able to kind of work to find answers to little tweaks that problems might be thrown in the problem at you, okay? All right, I will make one more video for combinations.